Yes, sir. Okay, dear student, good morning. Uh, Anyone, please unmute and tell me, am I audible or not, so that uh, we will continue. Anyone from the present student, Jose Supriya, Adesh, am I audible?
Yes, sir.
Yes. Okay, thank you. So, uh, once again, welcome you all in the power electronics lecture. So, in a previous lecture, last lecture that we tried to conduct, but due to less connectivity, internet connectivity, I cannot continue that lecture. But today we will start again unit number fourth, because the time for revision that is already consumed due to my medical issue. But now I hope you all are safe at your home, at your site, and we will start the unit number fourth from today. Okay, so again, because of less internet connectivity, uh, I require take some time, but we'll start with the unit number fourth, that is DC to AC converters. Okay, so DC to AC converters, already we have seen AC to DC converters, which are basically called as rectifiers or converters. Now this DC to AC converters are called as inverters. Already when we have seen AC to DC converters, in which if the alpha is greater than 90, that time the power is delivered from load to source. So that rectifier or converter is also work as an inverter in that particular situation, right? So this inverters, that is called DC to AC converter, where input is a DC source, maybe either from battery or from the rectified circuit or rectifier. Okay, so if suppose the AC is taken from sorry, maybe power supply, and if it is converted to the DC, and then again it is converted to the AC, so one of the question that will come into the mind, that is why this is necessary, that is conversion of AC to DC and again DC to AC, right? So this is required because in industry we required the circuit called AC circuit with a variable frequency. Okay, now we know that the line frequency, which is a 50 hertz and a constant, right? So this frequency, if it is a constant, then we cannot control the speed of AC motor or AC drives. So to control the speed of AC motor or AC drives, we have to apply the signal with a variable frequency. If you change the frequency, then your speed maybe changes. Otherwise, the speed of AC motor cannot be controlled. In a DC motor, if you simply control, or if you change the DC voltage, that is armature voltage or field voltage, we can easily control the speed of DC motor. But for AC motor, by changing voltage, the speed of AC motor cannot be controlled. Okay, because there is no relation between the voltage and speed of AC motor. So that in AC motor, we require a frequency, variable frequency. So how to obtain variable frequency? So there will be a frequency generators, right? So like RC oscillator, LC oscillator, but the voltage level of such oscillator is very less. You cannot achieve maybe a voltage in something kilovolt or maybe in a volt, even voltage, right? So the output of oscillators is very small, so we cannot use oscillator as an input to the motors or maybe a AC drives, right? So to control the speed of AC drives or maybe a AC motor, we require a variable frequency with a high voltage, right? So option is the inverters. Inverters not only use at home for emergency purposes, but the main use of inverter in industry is variable frequency to control the speed of AC drives. Okay, so DC to AC converter, that is called inverter. So you can apply a single phase AC supply to the rectifier. Then output of rectifier is a DC. After using filter, you can use that DC voltage. It may be a constant DC voltage, and that DC voltage you can apply to the inverter, so that again you will get constant DC to AC, constant AC, and frequency maybe either fixed or maybe a variable frequency. Okay, so single phase or three phase, both supply can be used. Again, why three phase is used, uh, or maybe a why a single phase is used? So what happens exactly? uh, the single phase inverters, it consists of uh, maybe single voltage, a single phase voltage, but in a three phase voltage, we require maybe a large voltage, and that is not possible with a single phase, because in industry, in some applications, we required a very large voltage, something in kilovolt. So by using single phase supply voltage, it is not possible. So we are using a three phase, because ultimately we have to convert that three phase voltage into the DC, and then DC is applied as an input to the inverter. So single phase full bridge inverter for RL load, then three phase voltage source inverter for balanced R load, variable frequency, control of three phase inverter. This is actually a syllabus of this unit I am reading in front of you. Need of PWM inverter. What is the use of PWM inverter? That we have to learn. Then voltage control of inverter using PWM. Then three phase PWM inverter. Then design control circuit for three phase inverter, that is a control circuitry. And then PWM IC, there are various ICs which are used for generation of PWM, so that you can have maybe a PWM, that is a pulse width modulation. This is actually a control strategy or control circuitry which is used to control the output frequency of inverter. And last topic is AC voltage controller. That is basically a stabilizer that already we are using at home for fridge or television, etc. So this is the syllabus. Then we will go for the objective. What we have to learn in this particular unit, that is called your objectives. So we will see just objectives of this unit: to describe the need and function of an inverter, to consider the operation of single phase, half bridge and full bridge transistorized inverter. See, describe the need and function of inverter. So already we have discussed about the need. What is the need of inverter? So in industry, inverters are required for conversion of fixed AC to variable AC. It means fixed AC, what is called fixed frequency, to variable frequency. So that is the need. Variable frequency is required because we are using AC drives in industry. Basically, DC drives are more accurate for speed control, but the maintenance of a DC drive is very large. So Nowadays is DC drives are replaced with AC drives in industry. So AC drives required variable frequency as an input so that you can control the speed of AC drives. So to achieve variable frequency from fixed frequency supply, that is a line frequency 50 hertz, to the variable frequency, we require a circuit, and that circuit is called as an inverter. So that is a need to control the speed of AC drive in industry. Second, to consider the operation of single phase, half bridge and full bridge. Again, as like your semi converter and converter, here again half bridge and full bridge circuits are there. So we will see what is a single phase, half bridge and full bridge transistorized inverter. Then to examine the operation and detailed design aspects of various voltage source bridge inverter circuit. We have to learn the various design aspects of voltage source bridge inverter, because there are two types of inverters. We will see that in classification, that is called voltage source inverter and current source inverter. So current source inverter is normally not used, and even that is not given in your syllabus. So voltage source inverters are mainly used, which is a part of your syllabus. So we'll see that one. Then third one, to examine the operation of three-phase bridge inverter with a different conduction mode. Again, different conduction mode, 120 conduction mode, 180 conduction mode, and so on. So we have to learn three-phase bridge inverter with a different conduction modes. Why three-phase bridge inverter? uh, because in motor, basically AC drives, which works on three-phase supply, so we required a three-phase inverters. So that three-phase inverter, at home we are using single-phase inverter, but in industry they required a three-phase inverters. So we have to learn three-phase bridge inverter with the different conduction modes. Then next, to consider the means of controlling a variable frequency inverter output voltage. Then see, as the inverter is circuit which converts fixed frequency to variable frequency, right? I'm saying fixed frequency to variable frequency. It means that you are applying AC from line frequency that convert to the DC by using converter, and that DC again converted into the AC with a variable frequency, and that's why I'm saying fixed frequency to variable frequency. Okay, so that is one main task or motto. And second one, even to control the output voltage, right? Frequency that can be controlled by using inverter circuit, but output voltage of inverter is also required sometimes to control, and that is a different technique or different part, that is to how to convert or maybe a variable voltage, output voltage, how to get variable voltage. And last, to introduce various schemes of pulse width modulated inverters. So this is learning objective, what we have to learn in this particular unit. Now we will start with the introduction. Definition, that is DC to AC power converters are known as inverters. Okay. In other words, an inverter is a circuit which converts DC power into an AC power at desired output voltage and frequency. The AC output voltage could be fixed at a fixed or variable frequency. This third line is important. The AC output voltage could be fixed at a fixed or variable frequency. Normally, the output voltage of an inverter is a fixed, at fixed or variable frequency. What is the meaning of this sentence? The output voltage could be fixed at a fixed or variable frequency. Your output frequency may be a fixed or may be a variable. Okay. Then this conversion can be achieved either by controlled turn on and turn off devices. See, the part of inverter, main component of inverter is the switching devices. Maybe a BJT, maybe a MOSFET, IGBT, MCTs, SITs, GTOs, SITCH. These are the different switches, or by force commutated thyristors. Depends upon application. Normally, the thyristors are mainly used for high power applications. Okay, so thyristors are used for high power applications. For low power application, even you can use other devices. Sorry. For low and medium power output, the above mentioned power devices are suitable, for high power output, thyristors should be used. No other option for high power applications. We have a device called as SCR, which is used for any high power application like AC to DC, DC to AC, or any other, even DC to DC and AC to AC. These are the four type of converters that we have seen in a first unit at the start of first unit. So these are the four type of converters. All these four type of converters, we can use a different type of switches like BJTs, MOSFET, IGBTs, MCTs, SITs, GTOs, or other switches. But for high power applications, we don't have any other option. We are always using SCR for high power applications. Okay, so this is the introduction. The output voltage waveform of an ideal inverter should be sinusoidal. This is again the most important issue. The output of any inverter, that is the shape of output inverter, is normally we can say that it is a AC, right? It is a sinusoidal. But if you see the actual output waveform, the shape of output waveform of any inverter is non-sinusoidal. Okay, even we have seen advertised maybe on television that pure sine wave inverter, right? So pure sine wave inverter is not possible uh, without some additional circuitry. So when we say the output of inverter is a pure sine wave, it means that some additional circuitries are used. For example, wave shaping circuit and some filter circuit. Filter circuits are used to remove some harmonics, and a wave shaping circuit which converts your non-sinusoidal, that is square wave or quasi square wave waveform into sine wave, that is close to sine wave, not a pure sine wave, but close to sine wave. That is possible by using some additional circuitry, that is called filter and some wave shaping circuits, right? But without these two circuits, no inverter is made by anyone which produce pure sine wave. Okay, so keep in mind the inverters are always a square wave or a quasi square wave inverters. uh, in some quality inverters, they are using filter circuit and wave shaping, so that you will get a sine wave which is again not 100% pure sine wave, but very close to the sine wave, so that inverters are called as a sinusoidal waveform or maybe inverters. And normally for uh, our home applications, square wave inverters can be used. No harm from the square wave inverters to operate your television, computer, or other home appliances. But in industry, they required a pure sinusoidal waveform, right? Square wave form cannot be applied to the AC drives, so they required a sinusoidal waveform. So in industry, normally three-phase inverters are used, which produces more accurate, we can say more pure sinusoidal waveform, so that the output of inverter can be directly used to control the speed of a motor. Okay, so pure sinusoidal waveform required in industrial application only. For home applications or other office applications, the inverters which produces square wave or a Cauchy square wave can be acceptable. Okay, so voltage waveform of a practical inverters are, however, non-sinusoidal and contains certain harmonics. So if we use some filter circuit so that we can remove the harmonic components, then square wave or Cauchy square wave voltages may be acceptable for low and medium power application. That already I told you, that is home application or maybe a medium power application, the square wave or Cauchy square waves are acceptable. And for high power applications, low distorted sinusoidal waveforms are required. So output frequency of an inverter is determined by the rate at which the semiconductor devices are switched on and off by the inverter control circuitry, and consequently an adjustable frequency output is readily provided. Now output frequency is variable frequency. So to achieve the different frequency, your control circuit must be capable to turn on and off the switches which are used in an inverter circuit with a high speed. So as your speed of switching devices increases, your frequency also increases. If the speed of switching devices decreases, then frequency also decreases. That we will see later on. But last 5 to 6 minutes are remaining. So everyone give your attendance in a chat box privately within a 2 minutes. You can start to give your attendance right now. After 2 minutes, definitely whatever your attendance, I will not consider your presentee. So just 2 minutes for giving your attendance in a chat box. Attendance must be given in a chat box privately. Everyone. Okay, one more instruction for you. After this lecture, immediately 10:25 at 10:25, you all have to join the session that is organized by Department of Electronics Engineering for you. The resource person is a very good person who is clear the CAT exam more than 3 to 4 times with a very high score, is one of the eminent personality. So you all are instructed, strictly instructed, as I'm a tutor of T2 batch. So I'll observe the attendance of all T2 batch students. So remember, everyone from all the batches, T1, T2, T3. Your tutors will observe your presentee throughout the session. So everyone must present for the session and join the session exactly at 10:25, because at sharp 10:30 the session will be start. So you have to join the session exactly at 10:25. Okay, so everyone now stop to give the attendance. Already your time is over. If suppose somebody is giving attendance after this time, I will never consider. Okay, so we will continue for this. Last 4 minutes are still remaining, so we'll continue. And after that, sharp 10:25, all the students of T1, T2, T3 batches must be join the session, and you have to continue the session till 1 hour. Just 1 hour session is there, so you have to listen the thoughts, whatever the preparation required for your uh, forthcoming maybe competitive examinations, and how to improve your communication skill, that he will deliver. So you all are instructed to strictly join the webinar sharp at 10:15. Okay, so next one is harmonic contents of output voltage can be minimized or reduced significantly by switching techniques of available high speed power semiconductor devices. You can have maybe a different techniques so that we can maybe significantly reduce the harmonic components, and even by using filter circuits which reduces the harmonic components, right? So that we can use. So filter of harmonics is not feasible. Some kind of filters can be used, but to remove the harmonic components, all the times maybe filter circuit is not suitable. So output frequency varies over a wide range, and the generation of AC waveform with a low harmonic content is important. When the AC output voltage of an inverter is given to the transformer or AC motor, this output voltage must be varied in conjunction with the frequency to maintain the proper magnetic condition. Therefore, the output voltage control is an essential feature of an adjustable frequency system, and various techniques for achieving voltage control are discussed in this particular unit, maybe at the last. Already we have seen that the voltage control scheme, if you see the syllabus, that is various to consider the mean of controlling variable frequency inverter output voltage. So output voltage of inverter must be controlled so that you can have maybe a stable frequency. So this is about the introduction. Now DC to AC converter. This is generalized block diagram. So when you start your answer, you can maybe write the definition. You can write some introduction part that I have given here in your answer. Then you can draw this simple diagram, block diagram, which shows that the actual working of inverter. As the input to the inverter is a DC and output is shown pure sinusoidal, but actually pure sinusoidal output is very difficult to obtain. But we can show that the output of inverter is a sinusoidal. So this particular block diagram, simplified block diagram, shows what is an inverter, right? So input is a DC, that is, this is a DC input, and output is AC. So inverter circuit which converts DC into AC. Okay. Then see classification. Classification is given on different parameters, different maybe kind of classification is given. So first classification depends upon the source, that is voltage source or current source. So already I told you that current source inverters is not a part of your syllabus. Voltage source inverter is a part of your syllabus. So according to the source of inverter circuit, maybe either voltage or current, the inverters are classified. Okay. Remaining classification we will see in tomorrow's lecture. So again I instruct you, all are immediately join at 10:25. Attendance is considered, and if you are not attending, then definitely you will be punished. So again I request you, everyone should join the session from T2 batch. I'll observe the attendance. Even T1 and T3 batch tutors also observe your attendance throughout the session. So it is compulsory to all. 68 students are present in this first lecture.